Yeah, I'm Simeon. Then today we're going to start a new topic, and it's called integration. Integration is actually antiderivative. Now imagine we have a function, and let's call that function f of x. Let's imagine we are given that df of x. Let's imagine that the time we find the derivative of f of x, it gives us g of x. Now, by given this function, that means if you find derivative of f of x, it gives you g of x. But now, if we now have to find, so if we now have to find we want to reverse, we want to find what gives us what will give us f of x back. And we need to find the integral of g of x dx is equals to f of x. This is c. So our c is called the arbitral constant. So we have that. So now, because this is a video and we can't, this is a video, and typing maths is quite difficult. So just take that if you find now this man, our f of x is called the integrand. So now we have some important integral. So the first one, and the most important, which I feel is the most important, is this: x raised to the power of n dx. Now if you're given something like that, the integral of that is x raised to the power of n plus 1 plus n plus 1 plus c. That's our first example. Now, let's see an example on that. Now, the first one that we are given, imagine we are given something like, we have to find the integral of x raised to the power of 5 dx. So you just follow the simple formula. Just follow that. So that will be x 5 plus 1 plus 5 plus 1 plus c. So we have that. Now what you now need to do, this one will give us x raised to the power of 6 plus c. So this is it. Now if you have something like this, x raised to the power of that, so we are still using this particular formula. So this one becomes x raised to the power of 1 plus 1 plus 1 plus c. So that gives us x raised to the power of 2 plus c. Now imagine we are just given x, we are just given the x. Now we need to take note that this man is same thing as, so that you not get confused, this man, this x dx is not ordinary dx, the same thing as let me just copy this. So this man is 1 times the x will still give us the x, and that the x that we are seeing is the same thing as, you can write this as x raised to the power of 0 x raised to the power of 0. So what we have now is much easier. We can now take the derivative, find the integral of x raised to the power of 0. So that will give us, applying this simple integration formula, so this gives us x raised to the power of 0, because anything raised to the power of 0 is 1. So that will mean for it to be 1, that means x must be raised to the power of 0. So plus 1 all over 0 plus 1 plus c. So this gives us x plus 1 plus c. So our final answer will be x plus c. So that's what we have for that. So this is somehow now imagine we are given something like 3x raised to the power of 3, let's say 2, the x. So this 3 is a constant. It's a constant. So we can just write this. You can bring out that 3. You can bring this 3 out of the integral. You can have 3, or write it like this. This is 2 plus 1 2 plus 1 plus c. So this gives us 3x cubed all over cubed plus c. So that will be x cubed plus c. Now I want you to take note of something. Now if you have kx to the power of n, the x, so you can bring out that k. You can, if you just be x raised to the power of n, the x. So invariably you have this. So you can say k, let's put it like this, x n plus 1 plus n plus 1 plus c. So we have that. So I don't want to make this video so long, so you can see this is our first introduction into integration, our first subtopic in integration. So, and I believe that with this small introduction you have a foundation of what integration is all about. Sorry, we don't have much space to be writing. I wish I could explain more. So you can just take, if you are given the integral of a function, especially this type, so this is what you use to solve this type of question, find the integral of that type of function. So in the next video I will go a step further so that we will have more grip on integration.